Righto, here's our video. Now, first of all, I want to point out that there's 91.2 kilowatt hours usable battery bank here. That's enormous. The array is constantly filling it up. Look, on this particular day, you produced 90 kilowatt hours. That's enormous. You got normal household use, yet look at these consumption figures. Look at this one. It's right up there at 109 kilowatt hours. That's enough to run a house for a week, the average house for a week. You've used it up in one day. So what the hell's taking all the power? This is insane. Here we've got a 51. This day here we're using 59. Now I was there on the weekend, so I only turned on the EV charger thereafter. So you can see this fainter section. Oh, can I zoom in at all? You can't read the figures on my... No, that's not working, is it? Oh, yes, it is. You can't read the figures I'm looking at in the box. I'm just verbalising them, so because your resolution's probably not great. The EV charger here should be dominating. It should be using 80-90% of your power, and your base load was 52. 52 kilowatt hours, only 30 kilowatt hours of EV charging. So I would say you need to put... What I'm assuming is you've got an overflow. Soon as the batteries hit 100%, which happens very regularly, because look at the solar yield, 72 kilowatt hours here. And what's happening here, once it hits 100%, your brick heater contactor pulls in to throw the excess power being generated by the solar to heat your house, which is great in winter. The problem is it appears that it won't turn off until the batteries are run down. Look at this date, 109 kilowatt hours. And it's not turning off because the batteries can't get down to 28% unless you use for a week's worth of power in one day, which you have here. The only explanation for that is that the heater isn't turning off when it's supposed to. So it's got about 2 elements in it, or 3. I forget, maybe they're all coming on at once. What's that? It's got to be 6, running flat out at 6 kilowatt hours. 6 kilowatts, I should say. It's got a thermostat, it's got a fan. The house should be hot. It wasn't when I went there. I don't know where this power was going, but I'm assuming the only thing is that it could possibly be is the heater. So turn that off because something's wrong with the off. It turns on as it should at 100% capacity, but it's not, because you're hitting 100% oil heaps of times there. And it's not turning off, however, which is the only explanation to get the batteries with a capacity of 91.2 kilowatt hours usable, 100 kilowatt hour nominal, or almost, something like 98. And you're getting down to 28% on this, whatever happened on this day. I can't believe it. And the solar must have been the worst day in history. Practically dark all day. They only produced 16.3 kilowatt hours when this is the middle of winter. We're talking June and July here, the worst part of the year. You're averaging kilowatt hours on a solar is more like 50, 60. Here we're doing 86. Here's solar 68. Let's have a look at some bad days here. 47, almost 50. Here's an average day here, 60. So we're looking 50, 60 average. That's twice the hour. That's like more than twice the house would normally use. So we have to turn off that circuit breaker labelled brick heater because it's the only thing that could be using it, all the power. Now, since I've been there around the weekend, you've used your EV charger. Now, your EV charger's only used 30 kilowatt hours here. That's 3 hours of charging flat out on your car. And there's a little bit here. Now, really, this graph should be inverted. You should be not 89% EV charge with about 20 kilowatt hours of usage. So, my advice is to turn off the brick heater circuit breaker. It's labelled in the main switchboard, because something seems to be wrong with the off timer, off setting. It should be turning off at maybe 80% battery, 90% not 28%. Something's wrong with the heater turning off, I think. It's using up industrial levels of power. As you can see, insane, 87 kilowatt hours usage on this day. That's not right. Turn it off, and we'll have a look at the figures, and turn the changeover switch on your EV charger from grid to off grid. So, or back up, because this should be dominating. Charge your car anytime you like. You don't have to charge it at off-grid rates between 11 and 7 a.m. and see how you go, because really I can't see what else could be possibly pulling at industrial levels of power. Use your reverse cycle air conditioning for heating in the house, because this system is, as you can see, could probably run 5 houses, but it's only running one house, and that one house is using as much power as 5 or 6 houses. So something wrong there. Got to turn off that heater and check this. We'll check the settings some other time. See ya.